Ozone, O3, may either warm or cool the surface of Earth depending on whether it accumulates in the upper atmosphere, the stratosphere between 10 and 50 kilometers above sea level, or lower atmosphere, troposphere, from the surface to about 10 kilometers. The following reactions generate ozone in the stratosphere. O2 plus ultraviolet radiation yields 2O. Oxygen plus oxygen 2 yields 2oxygen 3, or ozone. This ozone blocks ultraviolet radiation from penetrating the atmosphere and thus cools the surface. As discussed in the next section, certain man-made chemicals are depleting this ozone layer. In contrast, most of the ozone in the troposphere derives from photochemical smog. The summary reaction for photochemical smog is CO plus 2O2 plus sunlight yields CO2 plus ozone. Ozone produced in the troposphere acts as a greenhouse gas that contributes about 13% to global warming. Human activities are increasing tropospheric ozone. The last category of greenhouse gases that we will consider in this video segment is chemicals called chlorofluorocarbons, CFCs, and hydrochlorofluorocarbons, HCFCs. These compounds have carbon atoms bound to chlorine, fluorine, and in the case of HCFCs, hydrogen. They are highly effective as refrigerants, propellants for aerosol sprays, cleaning solvents, and bubbles to expand rigid and flexible foams. Unfortunately, they are also greenhouse gases with warming potentials more than 1,000 times greater than carbon dioxide. If this were not enough, these compounds catalyze chemical reactions that convert ozone and Earth's stratosphere into oxygen molecules. Consequently, the Montreal Protocol, an international treaty to abate the loss of ozone layer, severely limited the use of these chemicals. The banning of CFC emissions is having the desired effect in that atmospheric CFC concentrations have begun to wane. All in all, the influence of these compounds should diminish from about 7% of global warming forcing to less than 4% by 2050. This provides a clear example of how a cap on emissions of greenhouse gases can reverse their negative influence. In summary, number 1, global climate models depend on estimates of human greenhouse gas emissions. Number 2, estimates of human greenhouse gas emissions vary with demographic, social, economic, technological, and environmental factors. Number 3, the major greenhouse gases, carbon dioxide, methane, nitrous oxide, ozone, and CFCs derive from natural and man-made sources.